Hi everyone, this is Mrs. Hayes, and welcome to Chapter 2.4, Functions in Real Life. Hopefully you already watched video 2.3 about domain and range, because some of these questions have to do with domain and range in real life situations. So for exercise number 1, there's a graph, and it says the following graph represents the height above the ground versus time at a resort as Thomas rides his favorite ski slope. So all these are answered for you. If you just look at what I'm going to highlight on the graph while you read these answers, it'll make a little bit more sense. You have to determine or state the domain and determine what it represents. So the domain, I'm looking from 0 to 6, and we are including the 0 and the 6 on the graph, so there's brackets. And this represents the time in minutes, because I read the axis and it said time in minutes, that it took for Thomas to ride the ski slope, because it told us in the question he's riding a ski slope. So it looks like he went up the lift and then back down. But that's all they wanted for part A. Part B, state the range. So for range, I'm looking in this direction, low to high. So from 0 to the highest point, the range is 0 to 90. 0 is included and 90 is included. So those are brackets. The distance from the ground to the top of the ski slope was 90 meters. That's what it represents. The distance from the ground, which would be 0, a height of 0, to the 90-meter top. What might Thomas have been doing over the interval from 0 to 2, or time is between 0 and 2? So I looked from 0 to 2, and I thought it's a straight line up, and I thought that was most likely when he was riding the lift. It was a constant rate of change, and the change was 90 in 2 minutes. This is minutes. So that's 45 meters per second is the rate of the ski lift. And part D, what might Thomas have been doing during the interval 2 to 6? So that's after he went up the hill, he would be skiing down. It has a negative slope, so that made me think he was going downhill. And it wasn't as even as the motorized ride up the hill. His rate was changing a little bit. Number 2, the graph below represents the height of a ball. Over the time from 0 to 8, I look at my graph, it's in seconds, and the height is in feet. Let's see, so, question, it says, after how many seconds was the ball 11 feet off the ground? So I went to 11 on the graph, and it looks like that occurred at 4 seconds. So 11 down 4 seconds. The ball was 11 feet off the ground. I found my answer by finding 11 feet on the y-axis and saw this happened in an x value of 4 because it said explain how to find your answer. So the ball starts at the ground, goes up to a maximum height of 11 feet, and then comes back down. What does your answer indicate about the range of this function? Sorry, my pen's not working right. Range of this function is, again, from low to high, and that means 0 to 11 is the range, because the ball was at its highest point at 4:11, and 0 was the ground, so that was the range of the ball. Next page, exercise 3. A parking garage charges customers $2 for every half hour to use its garage. What would be an appropriate domain for this situation? So when I think of this question, I kind of try to think of it as a table. So in this question, we have half hours, or basically the time that the car is parked, and then the cost that you have to pay. So if you don't park at all, your cost will be 0. Every half hour, you're going to pay another $2. So 1 hour, $4. So an appropriate domain would sort of be the list of numbers, 0, 1/2, 1, you could say 1.5 or 1 1/2, 2, 2.5, and so on, as long as you're staying in the garage. It doesn't really go off to infinity. It would be until you leave the garage, right? Another way of saying appropriate domain is what types of numbers do you see here? And you could also stay less than half an hour, like for 10 minutes. So technically, you can see any number from 0 on up. T is greater than or equal to 0. And I'm going to say that these would be the rational numbers, because we don't usually measure time as like, the square root of 2. So rational numbers, that would be greater than or equal to 0. would be the types of numbers that you'd be seeing. Fractional or decimals, and we'd measure time with nice decimals. Exercise 4, which domain would be the most appropriate set to use for a function that predicts the cost of an internet service that depends on the number of minutes used? So if it depends on the number of minutes used, then this would be the time, 0 minutes, 1 minute, 2 minutes, 3 minutes, and so on. And every time you use different amounts of minutes, your cost increases. So if I look at my choices, integers could be positive or negative, so I'm not going to say it's integers. Whole numbers are exactly what these numbers are, no parts, no decimals, just minutes used. You could technically use parts of the minutes, like you could talk for half a minute, but the charge is going to be based on how many whole minutes you have used. So I'm going to just say this is a really good answer. Rational and irrational numbers both include negatives. So unless it had said positive or negative rational numbers, I don't like the way those choices are looking. Okay, exercise 5. The function, blah, 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 h of t equals negative 5t squared plus 25, represents the height in feet of a stone from the ground at t seconds after it's dropped off a cliff. I'm picturing a cliff, somebody up here with a stone, and it's dropping to the ground, right? What's a realistic domain for this function? So I'm seeing t and h of t. T is representing time, and the stone starts, I would say then, at time 0, and its height was at the highest point here. If the cliff was, say, I don't know, 200 feet, we'll say, however high the cliff was, then as time goes on, in terms of seconds, then the ball is going to go, or a stone is going to reach the ground eventually. So I would say the domain for this function would be I want to say it this way. I want to say that the domain is from 0 until time t. T is when it drops off the cliff. T, in this case, is the time I want it to hit the ground at. So let's just say it's starting at 0, and eventually some time period later at time t is when it hits the ground. So I'm going to say 0 to t. And t could be any number in there. It could be a fraction or decimal amount of time. So you could say positive rational numbers would be used to measure these time values in that interval. At some point, it's going to hit the ground. Okay, exercise 6. The graph below models Craig's trip to visit his friend in another state. In the course of his travels, he encountered highway and city driving. The assumption here is that highway driving is faster, city driving is slower, because you got more people, pedestrians, lights, all that good stuff. Based on the graph, during which interval did Craig most likely drive in the city? So we're looking for the slower interval of time. So I looked down at the axis and I said the intervals seem to be broken up 0 to 2, 2 to 2.5, 2.5 to 5. All I'm doing is I'm looking between these pieces of graph here, and 5 to 7. So from 0 to 2, it looks like he traveled how fast? He went 110 miles from here up to here. This is 110. And he did that in 2 hours. So he was going 55 miles per hour. Doesn't sound like city driving to me. From this time to this time, he really wasn't driving because his distance wasn't changing. So I did not say 2 to 3.5 because it appears that he may have stopped then. His distance was constant. And then I looked at 3.5 over to 5, and I saw the change in his distance jumped up to 200 from 110, and that's a change of 90 miles. in 1.5 hours. And if you divide 90 by 1.5, you get 60. So that's like he's going 60 miles per hour. Now to me, that seemed a little fast. So the last interval I looked for city driving was 5 to 7. So let me just erase this so I can write a little bit here. In the interval from 5 to 7 hours, he traveled 200 up to 230. So he went 200 to 230. That's 30 miles in 2 hours. He was going 15 miles per hour if you do that division. I think that sounds like the interval that he was traveling the slowest. So I'm going to say my answer is 5, 7. And I'm going to say that is because he went 15 miles per hour. The work that I showed also is part of an explanation, but you have to have some words there to explain. And the last part of the question, explain what might have happened in the interval between B and C, and I kind of already hinted at this. I'm going to say he stopped for 1.5 hours, and you can make up any reason you want to. I'm going to say maybe he had lunch. All right, that's it. Thanks for joining me.